Hey there, Uncle George and Alum TA. This is Tony out in California. I owed you a redo of Homework 2B, and again, I was halfway through it 3, 4 weeks ago, and I realized I was on the wrong path after talking to the professor, Uncle George. So I actually had to redo Homework 1, and when I redid that properly, then it lent itself to finishing Homework 2B. So I never posted what I had for 2B last month because it was basically related to homework 1, and since both were screwed up, it didn't really make sense. So here it is. It's late, mark it as you would. But basically, if you look back at the video for homework 1 redo, I'm using a cool data structure called a linked hash map. Um, Again, that keeps things in order. It automatically takes key value pairs as we build a graph and add edges. So it makes finishing homework 2B pretty easy because again, if we can just kind of pass the key value pair from the messages and then their output for the next task, for example, a sum, of T1 plus T2, and then T3 is a sum function, and then of course T4 would equal basically T1 plus T2. So um, I did not use reflection. I didn't need it because of this data structure. It does look like a cool trick. I saw it in your book, Uncle George, High Performance Computing in Java. But I saw object var equals new integer 5, var get class dot get name will return a type integer or string. I didn't need that because of the way I have things set up here. Basically, if I can just refer to the tuples and then get those tuple IDs or keys, and then get that from the hash map itself, it's really all I need. So also, Uncle George, you say get A, get B, or and then add left or add right. I don't call it that. I just call it message 1, get 1, message 2, get 2, and then message 1 input, message 2 input. So it's a little bit different, but I think I'm okay. I'm still going K number of threads. Basically, what I have to do is I have to add some more functions to homework 1, and you can see here, get sum of tasks. Again, this only makes sense for adding numbers, not tasks that are sleeping. So it's the same input file here. Anything that's sleeping, obviously you can't really. Well, I guess you could add sleep 10 plus sleep 50, but that's not the way I implemented this. I just basically made these functions to handle up summing numbers sequentially and in parallel. So I could, I guess, so you basically cannot equal sleep here, but yeah, I guess we could actually do that. So in the next task, we'll sum up the output from the two previous tasks or messages. Okay, so and we have the parallel version, which would take the local sum for each thread. So now if we go back to main here and construct the graph, very similar to homework 1, except now here. Again, we're using a getter from the parallel version of this class right here to get the local sum of that thread and add it to the previous sum. Again, that's how we're going to get some task parallel. Again, we're adding the output from two previous tasks in this current task. So this is the parallel version. You see we're creating new threads here. Oops, don't do that. Okay. Whereas the main thread is just for the sequential part. So, or capital T thread there. So, again, I'm making this distinction between sleep and sums. Sums are the only things that can be parallel and the only things that can take the output from other tasks to sum up. So maybe that's a bit narrow for what you wanted, but that's the way it made sense to me. You can see we also have the sequential sum of tasks, again the non-parallel version. So we're adding two sums, the output from two earlier tasks, but sequentially, not in parallel. We're not getting the local output. So if we run this, Um, you know, sum of task sequential is 4. Here's the timing, and the memory used. And of course, the parallel sum of tasks is also 4. Again, because we added here the sum of vertex 2, or basically the output of vertex 2, which is the sum of two numbers, 0 and 1, and then vertex 3, which is three numbers, 0, 1, and 2. So 2 would equal 3. 3 plus 1 is 4. So again, no cycles here. You know, no vertex has an edge of itself. So, and we're using k threads here. So again, did not use reflection. Did not need to alter your message class. You know, again, the way I have it is inside this class here, and given the data structure, modifying that, I get what I need. So again, look at these functions and look back to the video on homework 1 if it seems confusing. But basically, because I took the time to do homework 1 to redo it properly, it then lends itself to kind of finishing up homework 2B. I did not do the challenge of reverse Polish notation. It really does look like a cool assignment, but as you guys know, I'm having trouble with Dr. Laufer's class, Dr. K's class, and I'm just trying to get caught up on everything. So sorry for the lack of ambition, but it is what it is. Anyway, the main project is going great on the GPU stuff, and that's what we're going to focus on. So thank you very much, and this is all on the Trello card. I will speak to you soon.